Hey there, kiddos. Today we're going to talk about integer exponents because the next unit we're talking about is all about exponents and how they work with each other. Hopefully you know what an exponent is. If you don't, go Google that real quick because you're going to need to know it. So the first thing we're going to do is fill in this table. I'm going to get you started, then you're going to pause and finish, and then we'll come back and talk about it. So you see every single line, we've got an exponential form for our number, we have a decimal form for our number, and then we have a fraction form. These down here are grayed out because the whole numbers, the positive exponents up here are not going to have a decimal form. Only the negative exponents. We'll talk about why in a few minutes. But 10 to the fourth power is the same thing as a 1 with 4 zeros after it, so it becomes the number 10,000. Well, so this number 1,000 is a 1 with 3 zeros after it, so that becomes 10 to the third power. So there's some positive exponents. So I'm going to have you fill that in a minute. Now let's talk about the negatives. Hopefully you see that 10 to the negative 1 power here is the same as 0.1. A negative exponent gives you a decimal as a number instead of a whole number. So when I do something to a negative power, my answer is always going to be a decimal or a fraction. So it became 0.1, or as a fraction, 1/10. If you will notice, I can also write that as 1 over 10 to the first power, because 10 to the first power is just 10, and so they become the same thing. So you should notice this 10 to the first is just the opposite of this 10 to the negative 1. This one's negative, this one's positive. When I put it in the denominator, it becomes positive. So this one is going to be 10 to the negative 2 power. So that becomes 0.01. So I have two numbers after the decimal. Well, 0.01 you should recognize as 1 to the 100th, which is the same thing as 1 over 10 squared, because 10 squared is 100. And so again, my negative 2 here became a positive 2 when I moved it to the denominator. So pause for just a second. I want you to finish filling in the table, and then we'll talk about the rest of it. So here's our chart all filled in. The things I really want you to pay attention to are this column right here. 10 to the first power is just 10. It's a 1 with 1 zero after it, and this is true for any number. Any number to the power of 1 is just itself. I also want you to notice this one. This one is a biggie, and the thing about this one is I'm going to teach you the rule before I can tell you why that's the rule. It's going to be a couple days, but I will eventually be able to say this is why this happens. So that's kind of tricky, but that's what's going to happen. So 10 to the 0 power became a 1 with 0 zeros after it, so it's just a 1. This is also true for any number out there. No matter what number I have right here, if I put it to the power of 0, it's going to equal 1. And then here are your negatives. If you notice, they became these decimals, and then I wrote them as fractions, and then I wrote them as fractions with the exponent so that you could see the negative exponent, when I put it in the denominator of the fraction, became a positive exponent, and that's going to be part of our rule in just a minute. So let's do another example using different numbers. So Randy's a botanist. He works with plants, and he's taken over a study of a plant whose height doubles every day. So they have a plant, height is doubling every single day. Height of the plant is recorded on the table on the 4th day after Randy took over. So 4 days had gone by before Randy took charge. The plant was 16 inches tall. So Randy recorded the height and put it in here, and then he also wrote it in exponential form. We have to complete the table for days 3, 2, 1, and 0, and then we will talk about those negatives that are on there. So we're working backwards in our table. It does tell us that it doubles every day, but we're starting from day 4 and working backwards to day 0. So we want to cut our height in half every day as we're going through it, because we're doing the opposite. Well, 16 is the same as 2 to the 4th, because that's the same thing as 2 times 2 times 2 times 2. Those are the same thing. And if you multiply that out, it equals 16. So 8 here is the same thing as 2 to the 3rd, because I can do 2 times 2 times 2, and it equals 8. And if you will notice, the 2 came from the fact that we are doubling our height. My exponent is the number of days that have passed since I started my experiment. So this next one here, if I cut his height, the plant's height, in half again, now it's 4. In exponential form, that's the same thing as 2 squared. This is one you should know. Everybody should know 2 squared equals 4. Cut it in half again. On day 1, the plant was 2 inches tall, which is the same thing as 2 to the 1st. And so like I told you up in our chart a minute ago, anything to the power of 1 is just itself. So 2 to the 1st is just 2. Now to the 0 day. Day 0, where we started, the very beginning of the study. Cut your height in half again. Half of 2 is 1. So at that point, the plant was 1 inch tall. In exponential form, It's doubling for 0 days. Anything to the power of 0 equals 1. So that's how I can write it in exponential form. So up here, question 2. Question 2 wants to know, what does day 0 represent? Well, day 0, if you will remember from way before, when we're graphing at the 0 point, that's your starting point. So this is where the study started. So when the study began, the plant was 1 inch tall. So the next question says, what does day -1 represent in the study? Well, day -1 is 1 day before the study started. The plant still existed, so we still have a plant and it still has height, but this day doesn't count because it's the day before the study began. But we still call it -1 because the plant still existed. We still have a number. And if I cut my height in half again, it becomes 1/2, because half of 1 is a half, which is the same thing as 1 over 2 to the first power, because remember 2 to the first is 2. In exponential form, it's 2 to the -1. So you'll notice again, this -1 became positive once I moved it to the denominator. Cut this in half again. Well, half of a half is not a whole. Please don't say that. Half of a half is a fourth, which is the same thing as 1 over 2 squared. And in exponential form, it's 2 to the -2. And so here we go, negative exponent, positive in the denominator. So whole number, positive exponents are going to become whole numbers. You're going to get whole numbers as your answers. But when you get down here to negative exponents, your answers are always going to be written as fractions because they are part of something. If I'm doing something to the negative power, it's going to be a fraction.
I'm going to play again.
Okay, so now let's look at the back and let's talk about some rules. The first rule, this is your foldable, by the way. This part here needs to go in your foldable. So we have a to the 0 power. And like I told you, anything to the power of 0 equals 1. I can't tell you or show you why that happens for another couple days because you don't know the rules yet, but just know that that's the definition. So anything to the power of 0 equals 1. And it doesn't matter what it is. So if I do 15 to the power of 0, that equals 1. If I do a letter, x to the power of 0, that also equals 1 because it's to the power of 0. If I make it really, really complicated and I do a lot of stuff, x squared, y to the 4th, z to the 27th to the power of 0, that all equals 1. It doesn't matter what any of that stuff is. Now, the only time it gets tricky is if I throw in negative. So if I do this, if I do negative 324 like this, all in parentheses to the power of 0, then it equals 1. But if I do it like this, without the parentheses or with the negative outside of the parentheses, either one, that's going to equal a -1 because this negative is not taken to the power of 0. Even if the parentheses are not there, so if it looks like this, what they are saying is you want to do 324 to the power of 0 and the opposite of that, so that is still also -1 because the negative has to still follow. It doesn't disappear. So there is a difference between in parentheses altogether and not, but that's to the power of 0. Really easy. Now, negative exponents. Like we saw in our table that we did, when we do negative exponents, those answers are always decimals or fractions. And so if I have a number like 2 to the -3 power, that's the same thing as 1 over 2 to the 3rd power, because when I put this -3 exponent in the denominator, it makes it positive. So I have 1 over 2 to the 3rd power, and if I want to simplify that further, that's the same thing as 1/8. So it gives me a decimal answer instead of a whole number answer. So I get a decimal. It works with variables as well. So I can have a to the -8th power. Well, that a to the -8th has to move to the denominator, and it makes it positive, and then I just put a 1 on top. Now, if I happen to have a coefficient in front, for example, I do 3b to the -4th power. The -4 only applies to that b, so the only part that has to be in the denominator is the b to the 4th to make it positive. The 3 can stay in the denominator. I mean numerator, not denominator. It's in the numerator. The reason there's a 1 on this one is because, remember, there's an imaginary invisible 1 in front of that a that stays in the numerator. So why don't you, let's try this one. Let's do 2xy to the negative 6th. The only thing that has a negative exponent is the y. So the y moves to the denominator and becomes positive, and the 2x stays on top. Now, negative exponents work the same if for some reason it was in the denominator to begin with. So I have 2a over b to the negative 5th. Well, now this is negative, and in order to make it positive, I have to move it to the other part of the fraction. So now it has to move up. Well, the 2a gets to stay put, and the b to the 5th now moves up top with it, and it's now positive. So it depends on where it is. If it's in the numerator, you have to move it to the denominator. If it's in the denominator, you have to move it to the numerator. So it's all about moving them, but we don't like negative exponents in our answers, so you always have to make sure you move them so that they are positive. So we will practice this tomorrow when you guys come to class, and I will see you then.